Cal, today we are going to start talking about um, how we are going to display the data that we have talked about collecting and classifying. And now we're actually going to take some data and put them into some displays so we can see what they look like and we can analyze them. So the first type of thing we are going to do is called a frequency distribution. And this is a way for us to organize data. Right here, we have some data for the 50 wealthiest people in the world, and we're calling it raw data because it's not organized in any way. So we've just collected their ages, and what we want to do is organize it in some way that allows us to do some analysis. This is quantitative data. We can make these frequency distributions using quantitative data or categorical data. So this is quantitative because we can measure an age and we have a unit, years. And so what we would do here is we'd find the largest age or the largest number, and we find the smallest number. And we want to decide like how we want to break this up. So we have these things called classes. And what we're doing is we're breaking the range of ages up into equal sized classes. It's important that classes are equal sized. So you can see each of these classes contains 8 numbers. So this one is 27, 28, 29, 30, 31, 32, 33, 34, 35. And I was wrong, they're 9 because it includes the 27. So each of these contains 9 different possible ages that we would include in this class. So anybody aged 27 to 35, we would make a little tally mark to keep track of how many are in that class, and they would be in that grouping. Anybody 36 to 44 would be in this grouping, 45 to 53 in this grouping, so on and so forth. And then we can count them up and we can see their frequencies. What is nice about this frequency distribution is rather than looking at a group of ages here, not in any particular order, not organized, is I can see really quickly my biggest age group is 54 to 62 years old. Not many people were younger than 36. Only one is in the 27 to 35 age range, and then very few, only 2 people were 90 years or older in the 50 wealthiest people. So this type of thing helps us see what's happening with data a lot easier than just a bunch of numbers on a page. We can do the same thing with qualitative or categorical data. Here we have blood types. That's categorical. So we can separate our groups into blood type. Again, our groups are called classes. And then we can tally up the number of people in those classes. And of course, we can do the frequency. We can add numbers to it, but we can see the most people had type O blood here, and the least amount of people had AB. And we could take that even further and we can break this up into percentages that will allow us to make other types of displays that we'll talk about further in the future. So right now, the biggest thing about these frequency distributions is that they take a big group of data like this, record high temperatures for 50 states, and we're going to take these 50 data points and put them into an organized table so that they are easier to analyze rather than just looking at 50 numbers in maybe what is a confusing grouping. So we're going to construct a frequency distribution using 7 classes. And so what we're going to do is we are going to, and this is the same, these are the same values down here. So you should pause and you should make a table and then press play. And so we're going to take our biggest number, our highest temperature, and our lowest temperature, and we're going to subtract them to get our range. So our largest temperature in this data set is 134. Our smallest temperature is 100. And so that gives us a range of 34. We want to figure out how many temperature values are going to be in each class, and it's got to be in the same number for each. So we want 7 classes. That's what it asked for. So we're going to divide 34 by 7 and get 4.9. So we can't have 4.9 states' highest temperatures, but we can have 5. So we are going to round. So we're going to make this approximately, squiggly, double squiggly is approximately 5. So we are going to start at our lowest temperature of 100. And our first class is going to be 100 to 104. That might immediately look to you like only 4 temperature values, but 100, 101, 102, 103, 104, that represents 5 possible temperatures. And so I'm going to pause here and I'm going to fill out the classes. You can try that yourself too, where we have the next 5 temperatures. So 105 to 109 and so on and so forth. And then we will come back and take a look. So check your class limits to make sure they match with mine. We have 7 different classes. We're going to come back to the class boundaries, but let's do the tallies. So what you're going to do is you're going to pause here in a second, and you are going to put a tally mark for every temperature up here from 100 to 104. And so I'll just tell you right now, there are 2 of them, 100 and 104. And then I'm going to cross them out just to stay organized. So put a tally mark for the total number of temperature states, highest temperatures that belong in each class. And then press play, and I will have mine as well. So hopefully your tally marks match up with mine. And we can add the frequencies. That's the number of tally marks just numerically. So we had 2 here. We had 8 here. Sorry, my pen is lagging a little. We had 18, 13, 7, 1, and 1. And so what's really nice is instead of looking at just 50 numbers, now we can see that the record high temperatures in that occurred the most were 110 to 114. Very few got 130 or above, and only a couple were 100 to 104. And we'll talk in the future about the shape of distributions, and these tally marks actually make a really good picture of the distribution, how spread out the temperatures are. The next thing to talk about are the class boundaries. And so if we were to actually make a display of this data, we would want these bars to sort of touch each other. So we have these things called class boundaries. You can see that in between 104 and 105, there would be like a gap if we were to create a display. And so what we do is we set a boundary. So this bar, if I were to create a display, is going to go from 104.5 and then just bigger 109.5. And so therefore, this bar up here is going to go from 99.5 to 104.5. And this might make a little more sense when we start actually doing some other displays. So each of my classes are going to have boundaries like this. Hopefully you can see the pattern. So go ahead and pause and see if you can fill in the class boundaries. So hopefully yours matches mine. If it doesn't, please do, as always, as I always suggest, please do raise your hand and ask for help, and I can explain it to you further. So right now we're just looking to build these frequency distributions. So let's look at another one. And let's talk about how we can add onto it and make it a cumulative frequency distribution. So here we have the number of hours 30 college students said they sleep. Again, we have this unorganized set of data. This is raw data. And so we can start analyzing it by putting it in this frequency distribution. So I'm going to pause here, and I'm actually going to fill in the table, and then you can fill it in as well. So I filled in the table. I went with classes of just one value since this data wasn't spread out very much. And again, what's really nice when looking at this frequency distribution is we can see that 7 hours is the number of hours, the largest number of those 30 college students slept. And very rare for them to sleep 5 hours, very rare for them to sleep 10 hours. We're looking at the biggest chunk of 6 to 8 hours of sleep. And there we have, I copied this down further. And so now we can create this cumulative frequency where we start adding up, accumulating our frequencies as we go from top to bottom. So we have 0 students who slept less than 4.5 hours. And then 1 student who slept less than 5.5. That's this frequency right here. And then we get to the next one, less than 6.5. We have our 1 student here plus our 7 students there. So that's 8. And then we're going to add our 11. And then add 8 more to that. And you can see how we are creating this new frequency distribution by adding up all the ones that came before it. So if we had 30 students, then our total at the bottom should be that whole 30 students. So all of our students slept less than 10.5 hours, or they said they did. 29 slept less than 9.5, 27 less than 8. And so we can see 18 students are getting less than 6.5 hours of sleep per night. Just another way to display our data in a more organized fashion than just a bunch of numbers on a page. So I want you to try this one. You don't need to do a cumulative frequency distribution for this. Just try to construct a frequency distribution. Use 7 classes. So find your max, find your minimum age, subtract them and get your range, and then divide by 7. And that will give you the number of ages in each class. You can calculate tally the frequencies and try to create the class boundaries. If you're struggling with this, just let me know. And we will definitely talk about this at the end of, or the beginning of next class if we don't get to it while you're working on this lesson. Take your time on these and good luck.